Welcome back on lecture 3. Myself, Jai Tandil, working as assistant professor in electrical engineering of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. The subject static work control and harmonic filter. Subject code 3720736. Masters of Engineering. Lecture 2, we discuss the basics about PQ theory. So it is like the PQ is first transformation of voltage and current from ABC to alpha beta coordination, and then define the instantaneous power on these coordinations. So PQ theory also always considered in three-phase system, 3-phase 3-wire and 3-phase 4-wire we have, right? So that is today we are discuss with PQ theory in 3-phase 3-wire system. So first is zero sequence exceptions. We know that, right? Imbalance. There is no neutral. So before that, we are at the end of this lecture 2. We are getting some power value like that. We know that P and Q, that is consider zero sequence is absent V alpha, V beta minus of V alpha, I alpha and I beta now. So that is the instantaneous power equations of real power that will be flow in 3-phase 3-wire in form of alpha beta component. ABC we give to that ABC to form and the voltage form. So power is to be transfer, but active power is transfer and reactive power, that is something behind that. We will see what will happen in 3-phase 3-wire system. So whatever the equations we are considered in vector form first of all. So instantaneous voltage vector, that is considered for the voltage, that is VA plus J, that is imaginary, and VB. We know that we are not consider V0 because zero sequence is there is no shifting, so absence. So instantaneous voltage vector, that is a voltage vector E, which is called as a E, because laterally we need to do the apparent power. S is equal to P plus JQ or E into I conjugate. So we are considered the vector form without zero sequence component. So instantaneous voltage we are considered V alpha plus J V beta. Previously we are considered equation number 10, so I continued the theory with 11. And in instantaneous current, that is I conjugate, that is I alpha minus J I beta. That is equation number 12. Now in complex power, we can write S without zero sequence component. So S E into VI, we are considered VI. Power P is equal to VI. So S is equal to E into I conjugate. We can write V plus JQ. So for voltage vector, we have write V alpha plus J V beta into, for current conjugate, I alpha minus J I beta. So what will happen? Do multiplication. V alpha, that is multiply with both. JVB, that is multiply with both. So what I try to do, what is the imaginary that are separated and what is the real that are separated. So V alpha I alpha plus V alpha into J I beta. So V alpha into J I beta over here. J, that is considered as a common. Similarly, JV beta into I alpha, JV beta into J square. So minus 1, that is make plus. So J I beta. So we are separated V alpha I alpha plus VB IB plus J V beta I alpha minus V alpha into I beta. So that is a J term. So imaginary, so reactive component consider of power consider as an active component here. We are always try to make as a previous last topic equation number 10, that is PQ form. How this will be occurs by instantaneous voltage and instantaneous value of current we discussed earlier in a previous lecture. So following expressions of alpha beta, so PQ V alpha V beta minus V beta plus V alpha into I beta, equation number 14. We are trying to do ABC to alpha beta. Remember that. Now the following expression alpha beta current will be set as a function of voltage and the real and imaginary power in form of P and Q. So whatever the expression of alpha beta of the current will be set as a function of voltage as well as power, that is a real and imaginary both in PQ form. So whatever in previous equation number 10, inverse form suitable for the better explanation of the power defined in PQ theory. So whatever that equation 10, that will be inverse form. So whatever the I alpha, that will be here. As I told you, inverse of that means adjoint matrix divided by man of matrix. So V1 upon V alpha square plus V beta square in bracket V alpha V beta minus of V alpha, now it will change, and PQ, that is a, so now it will be in form of alpha beta form, equation number 15. Now equation 15, you can see in equation 15, that is a combine of active and reactive power. If suppose I want to separate, then what will happen? This V alpha V beta, that will be multiplied with here. So V alpha, that is with P, VB with Q. Similar that for IB, we can write 1 upon V square V beta square VB, but is multiplied by P and minus of V alpha, that is multiplied with Q. So minus of V alpha into Q and V beta into P. So that will be like, so I try to separate that active form and reactive form. So you can see there is a reactive power here, I am not consider 0, and here we are reactive consider, that is active 0. So I am trying to separate it, nothing else. So what I alpha I beta of equation 15, that is the same thing. We are consider only P over 0. Here we are consider Z over. So now we are separating this. So for that we can say, as I told you here, the current expression following here, the following expression alpha beta current will be set as a function of voltage and real and imaginary power, that is a current form. So we try to make this voltage and power form to the current form. So now what is it called? Alpha, we can say I alpha, that is of the active power regarding to. So I consider I alpha active power, similar I beta active power, plus here reactive form. So I alpha, that is in form of reactive, I beta, that is in form of reactive. So now individual separation of I alpha P, suppose we can say, so we can say 1 by V alpha square plus V beta square, that is same, and V alpha, because this V alpha, that is multiplied by here only, V beta, that is 0, so it will be 0. So what is the remaining term of that? What is the equation of I alpha P, I alpha B, that is the remaining V alpha divided by, that is the same thing, 1 upon into P, simple. That is equation number 17. Similar that instantaneous reactive current on alpha axis. This is regarding to the alpha axis, this is regarding to alpha, this is regarding to beta axis, this is regarding to the beta axis. So now reactive means Q term on alpha axis. So we can say I alpha is equal to reactive term. So V alpha, that is multiplied by here, V beta, that is multiplied by here. So V beta into Q now, that is the same thing. So here 1 by V alpha square plus V beta square, VB term, that is multiplied with Q, that is equation beta. Now B axis with active power. So B axis active power is over here. So now this thing is multiplied with here, and this thing is multiplied with here. So now what is the equation of alpha IBP? 1 upon, that is same, VB, that is multiplied with P. So IBP is equal to VB V alpha square, that is same, multiplied with P, that is equation number 19. Similar that for IBQ, this thing is multiplied with here and this thing is multiplied with here. But remember that the There is a minus. So we are getting minus of V alpha, V beta is 0, V alpha into Q. That is equation number 20. So it is look like complicated, but it is easy actually. So now instantaneous power on alpha beta coordination are defined as in form of P alpha, active power on x axis, alpha axis, active power on beta axis can be calculated from the instantaneous voltage and current on alpha beta axis. So now P and Q as equation number 10, P and Q of the alpha and beta, and now all this thing is V alpha into I alpha. Similar, the power P is equal to Vi, so we can write alpha. So alpha axis having a two vector, voltage vector and current vector. So alpha, V alpha and I alpha, similar to the reactive power Vi on both side beta axis. So now I alpha. So current, instantaneous value of current with active and reactive are different. So that's why I alpha, that is for 2. That is I alpha for active power and I beta for reactive power. Similarly, I beta for active power and beta for the reactive power. So V alpha, V beta, that will be same, but I alpha, that is 2 type. One is for the active power and one is that is for the reactive power. Right, that is equation number 21. Now we are getting instantaneous value of voltage and current. What is the third step? That is define the power, because that is the things according to the definition. I quickly further rewind the definition. PQ theory is first transform the voltage and current from ABC to alpha beta coordination and then define the instantaneous power. So third step is the power. So power, further, if current is in form of 2, so we can say, sorry, here is the alpha. The current that is in form of 3. So in a previous, we are getting so many equations, 4 equation I think, right? So if I want to write I alpha, then I alpha P plus I alpha Q, I beta, then I beta P plus I beta Q. So for power, what can I write? Power of alpha is equal to, so we can write what this, we just forgot this, P alpha is equal to, we can write V alpha, I alpha, alpha P plus V V alpha into I beta Q. So I V alpha, that is sorry, here V alpha, that is multiply with both, this thing is multiply with both. So sorry, these are the plus form, so additions of all. So V alpha 2 times, V alpha 2 times with the current of I alpha with active power and current of alpha with reactive power. So V alpha, I alpha 2 times, right? Alpha form. So V alpha, I alpha P plus V beta, I beta P plus V alpha, I alpha Q plus V beta, I beta Q. So alpha alpha 2 times, beta beta 2 times, alpha with P and Q, beta with P and Q. Simple. So that is a final equation actually of power. But we are getting this equation, instantaneous form of current. So that is actually I alpha P from the equation of here, I alpha P from the equation of 17. So we can write V alpha square plus V beta square into P, active form, because there is a P. So V alpha, and we are getting that equation 17 V alpha. So V alpha square, I directly write that into P. Similar V beta with I beta P. So I beta P, so V beta, V alpha square plus V beta square into P. So V beta and V beta, that is multiply V beta square, V alpha square plus V beta square into, that is further. So you have to keep in mind that that is a P. So here is P equation wise, plus similar that V alpha in form of Q form. So from the previous V alpha V beta V alpha square plus V beta square into Q. Similarly at beta Q from the equation number 20 minus of V alpha V beta V alpha square plus V beta square into Q. So you can see that there is a symbol of minus, negative symbol. Okay. So now what is the value, what is the reason of that negative and what is the impact of it, we will discuss. So that is equation number 22. Now further we have a PPQQ. So active form and reactive form, that is a separated. That is the reason of we are doing a Clark transformation. So now only the real power, we can say V alpha I alpha P plus V beta into I beta P equals to, we can write P alpha P plus P beta P. That is a alpha beta axis side getting a power, that is a active power, and alpha beta side reactive power, that is on the both axes. So only the real power, that is written by this, only the reactive power, that is written by this, which is indicated Q on both axes. Now from all the previous equations, like you can see this. So now we have a 4 power 1, 2, 3, 4. So similar that this, if we have a, you can see if we have a 1, 2, 3, 4 current, similarly now we have a 4 power, right? So power P, we can say it now further VI. Now the I is same, similar that here we are added only the voltage on that. We already did over here, but P form, P in active form, so that is called as instantaneous active power on alpha axis. Instantaneous active power. So what will happen over here? You can see this equation, maybe you can see easily. I am talking about this form. We have 4 power 1, 2, 3, 4. It will be one for the active, other for the reactive. So we can write V alpha I alpha P here. That is direct equal. I just write this equation and write the individual power name, that is called as the instantaneous active power on alpha axis, because it's having a alpha. Similar that you see that instantaneous reactive power on alpha axis, right? So we have a reactive component of V alpha. We find alpha. So we have a V alpha and I alpha Q. You can see over here V alpha and I alpha. So that is a alpha, that is regarding to alpha. We can say it is regarding to alpha. It is regarding to alpha, right? Means alpha axis, active power and reactive power. Similar that you can see that instantaneous active power on beta axis. So we have a beta axis VB. So we can write this is for beta and only the remaining term this is for the beta. So what I do that instantaneous active and reactive power on separate axes that are mentioned over here only, right? So that is the instantaneous power which is did by the PQ theory. Now I just conclude that some of the things that is actually most important to understand. So first conclusion is that the sum of equation 25 and 26 of alpha axis means whatever the addition of alpha axis both power, that is called as the instantaneous real power, and equation 26 and 28. So first of all first equation is, you can say 25 and 26. So 25 and 26 both are regarding to the alpha axis. Okay, so if we getting a sum, then we are getting the actual active power which is flow from that. But you see the second topic, that is the sum of equation 26 and 28. So 26 is over here, 26 and 28, you can see the similarity. There is a plus form and there is a negative form. So that theories prove that. I'm not saying zero sequence is absence on that, but actually the equation 26 and 20 of the reactive component, if summation, if we are adding of that, what will happen? Resultant is zero, because one is positive polarity, other is negative polarity. That means the neither make the contribution in the, we are getting the power equation, but there is no contributions actually of reactive component. They only give the magnitude only. I told you on starting, the beginning. So they neither make the contribution to the instantaneous nor the average flow between the source and load. So in three-phase circuit, there is a reason they were named instantaneous reactive power on alpha beta axis. So give the magnitude of the power flow. So P alpha and P beta. So as I told you, only source to load active power is flow, reactive power that having gives the magnitude for P alpha and P alpha. Now the last but not least, the imaginary power Q is a proportional to the quality of the energy that is being exchanged between phasors of the system. It does not contribute the energy transfer between source and load at a time. And we are talking about the time domain situation. Okay, thank you.